Hello. Now we are going to look at finding the sides of a right-angled triangle using sine, cos, and tan. To begin with, as we have to solve some equations involving fractions, we're going to do a recap of how to do that. So if I have x divided by 2 is equal to 12, how would I find the value of x? Well, I would get rid of my fraction. That would be my first job. So how would I get rid of my fraction? Well, I look for the lowest common denominator on both sides of the equal sign. Well, I have a denominator of 2 here, and I have a hidden denominator of 1 underneath my 12. So if I multiplied both sides by the lowest common denominator, which would be 2, that would get rid of my fraction. I'd be left with an equation not involving fractions, which is pretty much always going to be my first goal in trying to solve an equation like this. So I have multiplied by 2, because 2 divided by 2 is going to leave me with 1. So on the left-hand side, I will just have 1x, which is my goal. And then on the other side, I have to multiply by 2 as well in order to keep the balance of my equation. And when I do that, I get x is equal to 24. So 2 divided by 2 is 1, so I'm left with 1x, and 12 by 2 all over 1 is 24. If I have the x underneath the line, if it is the denominator, well, I still do exactly the same thing. It looks a little bit strange, but it doesn't really change anything. I look for the lowest common denominator, which is going to be x. So x and 1, x is going to be the lowest common denominator. So I multiply both sides by my lowest common denominator. And I have x divided by x is 1. So I am left with 1 times 5 is 5. And I have 20 multiplied by x is 20x. I've now gotten rid of my fraction, but unlike here, I don't have 1x. I want to get x by itself, as I normally would. So I now need to divide both sides by the coefficient of the x in order to get x by itself. 20 divided by 20 is 1. I'll be left with 1x here. So x is equal to, I have a common factor of 5 here, so I would end up with 1/4. So that's how we can solve our equations. And this is going to be the structure that we need for solving these equations involving sine, cos, and tan, but just practicing them with simpler looking numbers and letters. So let's get into using sine, cos, and tan to find our missing side. So we have a right angle triangle. I see I have an angle, and I see I have sides. So I immediately think sine, cos, and tan. So once I recognize that, I'm going to take a part of my page and I'm going to write down the rules for sine, cos, and tan. So as I see that I have my right angle triangle, I write down those tools that I have available to me. If I have a right angle triangle, I have sine, cos, and tan available to me, and I also have Pythagoras available to me. So which tool is most appropriate here? Well, I look at this angle. I have an angle of 40. And then I have 20 is across from the right angle, so that means that it is the hypotenuse. And A is next to the angle, which means that it is the adjacent. And the opposite side would be opposite over here. So I've labeled the sides of my triangle, and I say, well, what one of the tools I have available to me, sine, cos, tan, or Pythagoras, what gets me what I'm looking for? Well, I have an angle, I have the adjacent, and I have the hypotenuse. That's supposed to be a J. And when I look to my tools that are available to me, I see that cosine, cos, has the angle, the adjacent, and the hypotenuse. So I'm going to say cosine is the tool that I need in this case. So cosine or cos of 40 is equal to, I'll write it over here, 40 is equal to adjacent over hypotenuse, is going to be a, little a, all over 20. Adjacent over hypotenuse. And I've labeled my diagram with them. Now I just need to solve this equation. And it is basically the same structure as the first example we did here. So we need to get rid of the fraction. Before we do anything else, we need to get rid of our fraction. So the lowest common denominator here is going to be 20, because this is cos 40 all over 1, so it has a denominator of 1, just like anything that hasn't got an explicit denominator has a denominator of 1. So I need to multiply both sides by the lowest common denominator, which is 20. So I end up with 20 multiplied by cos of 40 is equal to A. Now at this point, my algebraic writing out is pretty much done. You can, for now, if you wish, put brackets around this to highlight the fact that it's multiplication, but writing a number in front of sine or cosine would be taken as being multiply, just like writing 20x means 20 and x are multiplied together. 20 sitting in front of cos 40 means 20 multiplied by cos 40. Now, it is a good habit to be in to do this in steps. So we're going to find out what cos 40 is, and then we're going to multiply it by 20. And this will help us in the long run. So when we put cos of 40 degrees into our calculator, and we have to make sure that our calculator is working in degrees and not in radians, we get 0.76604. We go to at least 4 decimal places in the middle of a question. And then for our final answer, we could go to 2 decimal places. So when we multiply these together, we get 15.32 is the value of A. And A is a measurement of the length of a side of a triangle. So if I'm measuring something like that, I should say units. I'm not given units in this question, but I know I have to be measuring in something to get a measurement of a particular length. So I have 15.32 units. And that's giving my answer to 2 decimal places, which would be the norm. So in the middle of a question, we would keep 4 decimal places. And for a final answer, we would usually have 2 decimal places. Now, let's practice this again. We have find B. So we look here and we say, well, I have a right angle triangle, I have angles and I have sides. So I'm thinking sine, cos, and tan. Which one is going to help me this time? Well, I have an angle here. I have opposite that angle is B, and then next to that angle is 8. So I have the angle, the opposite, and I have the next to is the adjacent, and up here across from the right angle would be the hypotenuse. So I've labeled my diagram. I now know exactly what information I've got, and I know what I need to find. I need to find B. So what links the angle, the opposite, and the adjacent together? Well, that's going to be tan. So tan would be equal to opposite over adjacent. So tan of 36 is equal to opposite B all over adjacent 8. And now we're very much back to what we had before. We want to get the lowest common denominator. Again, we just have denominator of 1 here, so we just need to multiply both sides of the fraction by our lowest common denominator. Because 8 divided by 8 will leave me with 1. I can actually cross that out. I can cross it out here as well. So 8 divided by 8 will leave me with 1, so I'll have B by itself is equal to 8 multiplied by tan of 36. And now I can find out what tan of 36 is. And I get that it is 0.72. And when I put it in the calculator, I get B is 5.81 units, rounded to 2 decimal places. Now let's try and find C. So I have a right angle triangle, so I know the tools available to me. I have an angle, I have the hypotenuse, and I have the opposite side. So I have the opposite and the hypotenuse, and then next to my angle would be the adjacent. So I've labeled my diagram. I recognize I have a right angle triangle, so I know what tools are available to me. And now I'm going to say, well, angle, opposite, and hypotenuse, well, that's going to be the sine. So I know the sine of my angle is what I need. So I write down the tool I am using, opposite over hypotenuse, and then I say, well, sine of 25 is going to be equal to opposite 13 all over C for the hypotenuse. But now I see I have something like my second example. Now I have the letter underneath the line. Well, it doesn't make any difference. I still want to get rid of the fraction. So I'm going to multiply both sides by the lowest common denominator, which is C. So C divided by C is 1. So I end up with C times sine 25 is equal to 13. Now I want to get c by itself, so I can divide both sides by sine 25. Because sine 25 divided by sine 25 is just 1. Anything divided by itself is just 1. So I have c is equal to 13 all over sine 25, and then I just put that, I put sine 25 in my calculator, and then I get 13 divided by my sine of 25, and I get 30.76 as a final answer. And again, I'm always going to at least 4 decimal places in the middle of a question when I find out my sine, my cosine, or my tan. And now, if I want to find x here, well, I have x is involved in this right angle triangle on the right, but I don't have another side to work with like I've had before. So in a question like this, I have to step back and say, well, what other information have I got? Well, I have this right angle triangle here. It's a right angle triangle because it's a right angle here, and that's a straight line. So that's a right angle too. And I have 15 and 9 here for these two sides. If I found this third side, then I'd have a side in the triangle that I want that would allow me to figure out what x is. So I'm going to call that y, and then I'm going to say, well, what tools do I have available to me that would allow me to find y? Well, I have two sides of a right angle triangle, and I want to find the third one. Well, I know a formula that connects the three sides of a right angle triangle together. That's going to be Pythagoras. So let's use Pythagoras then to find the value for y. H squared is equal to a squared plus b squared. Across from my right angle is 15, so I have 15 squared, subbing in brackets all the time, equal to y squared plus 9 squared, and solve this. So I get that y would be equal to 12. Now when we take the square root, we could always get plus or minus as an answer, but because y is a physical length, I'm going to say that I'm only going to be interested in the positive result. So taking a square root technically could be plus or minus, but because this is a length, we only take the positive case. Now we need to go in and fill that information into our diagram. We now know that y is 12, so this side length of the triangle that we're interested in is 12. So now I know I have, now that I'm dealing with this triangle, the hypotenuse is x, and if this is my angle, then this is the adjacent. And then opposite at 50 would be the opposite side in this right-hand side triangle now. So now I can look and say I have the adjacent, a hypotenuse, and the angle. So that's going to be cosine. Cosine is what I need. And I sub in, and I now need to solve for x. So I need to get rid of this fraction. So I have my lowest common denominator of both sides is just x. So I multiply both sides by x. X divided by x is 1. So I'm left with 12 on the right-hand side. And x times cos of 50 is equal to 12. I want to get x by itself, so I need to divide by the coefficient of x, or the thing that x is multiplied by. So cos of 50. I have to divide both sides by cos of 50. When I have done that, I get at x is equal to 12 all over cos 50. I find out what cos 50 is to 4 decimal places, and then I have 12 divided by that gives me 18.67, and I know I'm measuring in some units, so I say units to indicate that I know I'm dealing with a length of something. And that is what we need for finding our sides. This is more of a problem-solving type question, and we have to be able to say, well, I have a right angle triangle, so I know the tools available to me. I write them down and I say, what connects the information that I am given? I have angles, I have adjacent sides, hypotenuse, opposite side. What tool that I have available to me is most appropriate here? And we have to be able to understand these tools well enough to be able to use them for when we get more complicated questions like this. And that's what we need for now.